So section 8.5 talks about angle of elevation and angle of depression. So elevation, think going up, depression, going down. So if you feel depressed, you're down. Elevation, elevator, going up. Those are things you can think of. So angle of elevation, the angle formed by looking up from a horizontal line. The key thing is you need to have a horizontal line in order to have any angle of elevation or depression. So your horizontal line's here, you're looking up 38 degrees is your angle of elevation. Angle of depression, you're formed by looking down or going downward, but again, you have a horizontal line. You have to have a horizontal line and then your angle going down. So that would be your angle of depression. The reason that I'm emphasizing that is if I gave you a story problem about a hot air balloon and you're looking down 38 degrees, how far up are you from the ground? Well, when we think of looking down, we tend to put 38 degrees here, but you can only have angle of depression, angle of elevation with a horizontal line. So this is a vertical line, so this cannot be your angle of depression. So you have a horizontal line and then going downward, that is your angle of depression. So always have to have a horizontal line, not vertical. So for the example, angle 1 and angle 2, so angle 1 you have a horizontal line but then it's going down, so angle 1 is the angle of depression. And then angle 2, you have your horizontal line and it's going upward, so angle 2 is angle of elevation. Well, what you should notice is they're the same angles, because if you have two horizontal lines, those are going to be parallel because they're both horizontal. Then you have alternate interior angles, so those would be the same. For number 2, you have example 2. You have a surveyor stands 200 feet from a building to measure its height with a 5 feet tall finger job. Okay, so what this means is you're working to measure, and you might have seen these machines before. People look through them, but this is measuring distance. So it's telling you that this is 5 feet tall. The surveyor stands 200 feet from building, so from here to here is 200 feet. The angle of elevation to the top of the building is 35 degrees. So I'm going to get rid of this markings. I didn't put it in a great spot. So just imagine that you're looking, this is you're looking through this little machine. So act like that's you, not this one. So this machine is 5 feet tall. It says you have an angle of elevation. So keep in mind, elevation means up, but you have to have a horizontal line as well with it. So here's your horizontal line, and you're looking up. We're not looking up from the bottom. So we're looking through this telescope surveyor machine. They're telling you this degree is 35 degrees. It wants to know how tall is the building. Well, if it's 200 feet from the base to the bottom of the building, it's 200 feet from the eyes to the building. So I'm just going to bring up at 200 feet. We're trying to find x. So we have opposite, and this is adjacent, because this is hypotenuse. So I'm going to do tangent. So tan of my angle equals opposite over adjacent. And then we're going to cross multiply. So we have x to equal 200 times the tan of 35. So x is going to equal 140. Doesn't tell me how to measure it, so I'm going to do the nearest hundredth, because when it doesn't tell me, I'll just do the nearest hundredth. So what tends to happen is we stop here, but this is not your answer. This is part of your answer, though. You know that from here to here is 140.04 feet. We want the whole height, so we have to figure out what the length is from here to here. Well, it's the length of that machine, which is 5 feet. So we just need to add 5 feet to this total. So 145.04 feet. Now, obviously this is not drawn to scale because it looks like your 5 feet is the same length as 140 feet, but just kind of giving you an idea that when your eye level is your horizontal line, your angle of elevation, and then you might have a little bit that you have to add in. In this case, we had to add in that 5 feet.